I will introduce the application of the permanent magnets, and I will focus on the motors because it is the most common. And as we know, the global warming is getting worse, so people pay much attention to the we call sustainable energy, such like wind energy or solar energy. And for the transport in our daily life, the concept of sustainable transport is valued. And a classic example is the electric vehicle. And there are many components in electric vehicle, and motor is one of the most important components that will affect the performance of the electric vehicle greatly. And these are three common motor types we use in electric car. They are induction motor, permanent magnet motor, and switch reluctance motor respectively. And this table shows its pros and cons. And as we can see, the induction motor and switch reluctance motor are not suitable for electric vehicle because they are too heavy and their size is too large, and also it has lower conversion efficiency. So the permanent magnet motor seems like the best choice for us if we want to apply this motor in electric vehicle. However, it still has some drawback like thermal stability and the magnet source, especially the rare earth element, and this part we will discuss later. And these four magnetic properties are used to compare the permanent magnets. First is the resonance, which measures the magnetic field, the strength of the magnetic field after you magnetize the magnet. Second is the porosity, means the material's resistance to becoming demagnetized. Third is the energy product, means the density of the magnetic energy. And the last is the Curie temperature, is the temperature at which the material will lose its magnetism. And when we choose a material as a permanent magnet, this property has to be considered. And it is the comparison about the magnets and their magnetic property. And we can see that the neon system has the best performance in resonance, porosity, and energy products. And that's why we choose, most commonly, we choose the neon system as a permanent magnet because especially its high energy products, we can reduce the volume of the magnets as much as possible. However, it still has some drawback. It has low Curie temperature, and they will confine its application. As to the practical application in motor, we have to face two problems. The first is the thermal stability. As I mentioned before, the neon system has relatively low Curie temperature, and we can improve this thermability by adding some cobalt elements. Second is the corrosion issue. And we can solve this problem by making a surface coating. Like we can deposit an aluminum or nickel thin film layer as a barrier layer to prevent the magnet from oxidation. And we know recently that China reduced its exploitation of the rare earth element, and that's a big impact. So some automakers have to take some strategy to deal with this situation. And generally, we can divide this strategy into two parts: technical strategy and non-technical strategy. For the technical strategy, we have four directions to follow. First is we can reduce the rare earth element percentage in magnets. Second is we can employ rare earth element-free magnets like nickel and ferrite magnets, and also the novel material iron nitride. Third is we can develop other motors like induction motor and switch reluctance motor. But if we want to apply this motor in real application, we must to reduce their weight and size. And the fourth is the recycling technology. And for the non-technical strategy is to exploit new mineral resources. And to summarize our presentation, in the beginning we introduced samarium cobalt and neon magnets about its basic material property. And then we introduced some method to strengthening these magnets, and we introduce a new material which is called iron nitride. And finally, we introduce some application, especially in motors. And that's our presentation today. Thanks.